Do you believe that in smart manufacturing process, there will be more and more AI chip required in this process?
Yeah, of course. Because when you want to do more thing in smart manufacturing, of course you need the AI chip to drive the entire process.
Do you know there is a biggest event going on? Just went on the other day related to AI chip in Malaysia.
So if you want to know more,
yes,
that's Sembang AIoT.
Hello. Very good evening, good afternoon, wherever you are. Hi, my name is Cecily.
Yeah, my name is 𝐴𝐚𝐲.
Thank you for watching our Let's Sembang AIoT again. Today is a Friday evening, 4 o'clock, our usual time. So today is episode number 89 of our Jom Let's Sembang AIoT. How do you feel? Do you, after doing so many episodes until now, do you feel tired or do you feel regret?
I feel nothing for me.
Nothing, okay. That's good. I mean, not regret. Regret is why we start early, so we have to complete. Because our target is to do 100 live, So that was started 2013, mid of 2013. So the overall, let's say we want to do 100 videos every week. Practically, you need to have about almost 2 years time. 2 years time. So we are near to that. Anyway, thank you for watching Jom Let's Sembang AIoT. I don't know whether you can hear me well. Sometimes the mic may not be working properly. Is that okay? Is my mic okay?
Yeah, I think it's okay.
Hello. Yeah. Sometimes when I'm speaking, the mic can get disconnected in the previous section. So yeah, do you know there is one of the event, very big event. It's kind of launching and it's kind of collaboration between the Malaysian government and the biggest what we call so-called semiconductor IP licenses company, which is 𝐴𝐚 Holding from this British. That event just the collaboration just launched last 2 days on the 6th of March. Yeah, that was the AI chip that's related to AI chip. There is collaboration between the 𝐴𝐚, the company 𝐴𝐚, having a collaboration with our Malaysian government in promoting the made by Malaysia AI chip. Made by Malaysia, not made in Malaysia, because you can see a lot of this chip that they produce made in Malaysia. The government is trying to promote made by Malaysia. Made by Malaysia. That means the whole IC design in Malaysia. So, does it sound great to you? Okay, we welcome any feedback or any comment from you. Let's say you are watching us right now. Please do give us a comment and give us some idea. Let's say you have some idea to that. So talking about AI chip, okay. So AI, artificial intelligence, in terms of AI computing, high power computing needed in the whole AI process. We heard many times about that.
Yeah.
So what is so special about AI chip? What do you understand about this AI chip?
AI chip, I think, is a chip that specialized doing some AI tasks.
Yes. A specialized task that can be performed by a single chip. That is the AI chip that we are talking about. So of course, this is not new. This is not new. In fact, if you can find in some of the camera, some camera will be built in this thing, right?
Yeah.
Having this algorithm, actually train the model, where they actually put it into a semiconductor IC there to perform the task that it's supposed to do. That's very specific, dedicated AI task that the chip is performing. That AI chip that we are talking about. Not so much on the big GPU, right now, big GPU, who are the very good GPU producer right now?
NVIDIA.
Of course, NVIDIA. Of course, it's AMD. Of course, Intel also is part of it. Yeah. So AI chip is so spacious that it is performing a certain different function. That's why I think the government is on the right track, where I see many different possibilities within the AI realm. Certain applications they require more dedicated functions stuff. Yeah. So for example, if I say right now we are talking about smart manufacturing, that AI chip is actually quite relevant. So before we come into this more detail of AI chip, let's see. Okay, maybe we can you play can you play one of the slide? So this is the event that on the 5th. Sorry, it's on the 6th. On the 5th. On the 5th is when? On the 5th is yesterday. Yesterday.
Wednesday.
So that was the day. We can see the PMX, is holding the chip. That is, I think that's a fake one. I don't know if it's a fake one. But then it's powered by this ARM, so called powered by ARM. So if you look into a little bit more detail about this ARM, you'll see, Can we have the okay, can you go one step? Okay, so it's the arm, not the leg. It's the arm and not the leg. So arm is very, very special. I think at one time arm was, I think it was in Intel before. I think somehow Intel for very, very long time ago. I don't know whether it's the same arm. It's one strong arm thing. So, but anyway, it is an arm. It's not a leg. So ARM Holding PLC. This one is the company is in the UK. So we have. So if we're talking about ARM, so ARM is one of the semiconductor IP company. Design and license more CPU. They have GPU also. Of course, they are talking about embedded GPU, not so big kind of GPU that they're talking about. So embedded GPU, and also, of course, the AI chip architecture. AI chip architecture. This company actually they don't produce. They are not a fab house. They are not a fabrication house. They are not doing manufacturing also. They just design and also they own the architecture, and then they license to some of the people and developers who want to make a specific AI chip or specific microprocessor, and not microprocessor design, but based on RISC-based this RISC-based kind of thing. So RISC architecture is one of the key things. High efficiency and low power. So for those of you who first time you are hearing this RISC, I think of course RISC is very famous. 20 plus years ago, it's called reduced instruction. It's a kind of reduced instruction kind of architecture, where like for most of the x86, if you look at those Intel, AMD, these are all x86 platforms. And x86 platforms, they are using not a RISC. It's called a complete kind of instruction thing. So I will talk about that a little bit more, since we talk about AI chip, that we relate this ARM adapting to the current AI development, especially in this producing of AI chip. So of course, this set of things from ARM are mainly mobile and also embedded market. Not so much on the high performance type of computing. It's more of this set. And then for the ecosystem, they actually the most of the ecosystem and partnership are mainly from, let's say you can see this ARM NVIDIA. This is one of the NVIDIA. Talk a little bit more about this one. NVIDIA, they have this ARM built-in, right?
Yes.
They have the ARM for the processor built-in, and of course the GPU is using the NVIDIA. They use the processor part on this ARM. So of course Apple, iPhone, Qualcomm, Samsung, Huawei, these are the people who are in the ARM ecosystem. Meaning they actually get this design architecture, then they modify based on that ARM architecture to produce their own so-called their own chip, their own type of processor for their application. Let's say for iPhone, that is for iPhone. It can be for many other things. These are the key things that I'm doing. Of course, ARM is right now an IPO company. It's actually acquired by a SoftBank, and then I think in UK like that. So they are already IPO in 2023. So that is a little bit history about this ARM. Of course, ARM has been existing for a long time already. But then this is what they are doing. So okay, let's move on. Okay, let's talk a little bit about this CISC and IRSC, RISC and CISC. Okay, RISC, is a reduced instruction architecture. So CISC is more complex instruction. Complex instruction, these are x86, Intel, AMD, all using this type of instruction. So of course, using the complex instruction, it performs multiple tasks in a single command. Later on, you can see at the lower part. Let's say for assembly language, multiplying A and B, So with this this instruction, so at the back it's doing a lot of things. Like go and multiply A and B, and then they put they store at certain place. So by single instruction like that. So that is called more complex. More complex meaning there are many other things running at the back. So of course, some of the features of our CISC is variable length instruction. It can be long, can be short. More addressing mode ways to access memory. They have a different way of more type of addressing mode to access the memory, and require fewer lines in the assembly code. Fewer lines, but process at the back. There are plenty of process going on. That's why it eating up more power. Usually eating up more power. So of course. Where else, if you look at the reduced instruction, it's a fixed length, simple instruction, like you can see, load R1A, so you just do one thing, one task. Load R2B, so you load B to R2, B to R2, and then multiply R1 and R2 and store C. So these are reduced instruction, not so much complex instruction. So with this type of RISC, somehow it more less power, less thing going on, less transistor power being eaten in the whole semiconductor. That's one side. So of course you can compare. Let's say you want to compare the advantages of RISC and this RISC. Let's look at the advantages of reduced instruction. So you can see so of course you see RISC. You have a faster execution per clock cycle because this instruction is less more power efficient. Of course, it needs less power, ideal for AI accelerated and high performance parallel computing. That's why if you look at some of the devices produced by NVIDIA, Jetson, why they didn't use Intel CPU.
Because they want to consume less power.
They want to make more edge, less power thing. That's why they use this one. Of course, they know the GPU that they produce already having a high power CPU by Intel is already supporting them. That's where they put all the GPU cards. You want to do this one, they will go into that kind of ARM architecture to do that. That's also why after I do some study, that kind of collaboration between the Malaysian government and this looks great, I would say. Maybe we are on the right track. Because big company like NVIDIA also do like that. So of course, that can be one of the direction. So that is one part. Okay, let's take one more here. So of course, how does this how does this ARM actually license for this AI chip development? Okay, there are 3 or 4 things. One of them is Cortex CPU for the AI base. Cortex is this guy also running on Cortex.
Yeah, this one is Cortex.
Like 𝐓𝐸𝐷 Agent 200 also using a Cortex processor. That's a CPU processor. Mali and Immortalis GPU. This we seldom have heard. These are the place where this ARM has having this kind of GPU that actually can embed together.
Usually in mobile phone, the Mali GPU.
So, you heard about that?
Yeah.
Okay. So that is for imaging, gaming AI, AR, VR, or something, some application like that. So the third one will be the 𝐓𝐴𝐴 NPU. They also have this neural processing unit. That part also I never heard about this NPU. Of course, we heard about Intel having NPU.
Yeah, 𝐓𝐴𝐴 I also seldom hear.
So this actually is designed for maybe with a very efficient AI workload, edge device, something like that. So the very first NPU that you saw is Movidius. Intel Movidius. And then right now you can see some in the market. 𝐴𝐼𝐿𝐿. 𝐼𝐿𝐿 is also another set of things, but maybe not so much ARM thing. That's by itself. It's very proprietary kind of thing. So those NPU we are talking about, neural processing unit. And then the last one is some customized AI instruction. This is much more deeper. It's scalable vector extension. That some of them can be used for some more machine learning, AI analytic thing. That's why I pointed out to you that �nyML, one of them, can be one of them. Maybe Kenneth will want to extend a little bit more on that area. So to sum up, why this AI is able to. So okay, let's move on from here. So what are the market focus in this, say, ARM, compared to the existing x86 Intel? Of course, you can see all the ARM on the left-hand side. The smartphone, this ARM is practically you see everywhere. You don't see Intel in the smartphone. Laptop, yes, both of them. Data center, also both of them. Intel also having, ARM also having that thing. IoT and embedded system mostly are happening in ARM. Where this guy is edge AI is a concern. That is one. Automotive usually are more ARM based. I only realized that Tesla probably is also being user of this ARM thing. But in detail, I don't know. Maybe they have a combination of different kind of processor they use. High performance AI, of course, both of them. Right now, we can have both. Of course, high performance one on the x86 one will be more. So that is the whole. Whole summary. Very quick, small summary. Just want to make this this kind of AI collaboration made by Malaysia kind of AI chip where can they go? Are they on the right track? This is a very simple summary, which I think, what do you think about this part? Of course, we did never go and evaluate this part, but all of a sudden this thing is a surface, but make us be curious, whether that thing is worth or that is the right direction. Of course, the government has got more intelligent people looking at that. But as a layman, you look at it. What do you think about that?
I think if everything is made by Malaysia, are we going to get some cheaper AI chip or not?
Okay, that's another thing.
Yeah, another thing is I think US also have a lot of restriction on the exporting their AI chip. So it's a good timing for Malaysia to start our own AI chip.
Okay. So that is another challenge. I would say that's another challenge. Of course, making AI chip, maybe you can make, but then in terms of competitiveness in manufacturing, in marketing, in the usage of it, and things like that, there are many factors like that. Making, I don't think is an issue. With the reference design, probably you can do that because you license the thing. The basic architecture already there. It's actually not so hard. Not so hard. But of course, when we say not so hard, it's not fair also. But those are people who are injecting, you have all these things. Just like you design some reference, like Intel give you some reference design, you just follow. Actually, it's not so difficult. Whether or not you can make it more cost efficient, power efficient, stability, or different, able to handle certain tasks of the AI, that can be another challenging part. So, okay, since we talked about this set of things and then how does this thing relate? Maybe, you want to discuss maybe one or two examples in terms of AI chip. How can this be applied in the so-called manufacturing facility? Since we talk about smart manufacturing, how can you use the AI chip to do that?
In smart manufacturing, okay. First of all, the AI chip got different category. So actually, before the start of the AI chip, before we have the AI chip, last time people used the depends on your application. So if your application is related to the voice, the natural language processing, so you might need to use a DSP, digital signal processor, to do this thing. You need to run some AI in the digital signal processor. So to further talk about this one, we will move into our first slide first.
Okay. Let's move on.
So I think for those who are using the Android phone, so you should not very familiar with the OK Google, the voice command to activate your phone.
Is it? This is not Siri. Siri is iPhone.
Siri is iPhone.
Google is Google.
This one is Google because we are talking about the ARM thing, right?
Okay.
So that time, OK Google exists many years already, even before the AI chip started. So what the OK Google do is the phone, it will continuously listen for this command from the user. And then usually when we power off the phone or we just turn the screen off, the main CPU is not doing much of the job. And then we need some chip to continuously listen for this command from the human. So what the Google do is they use a very small neural network, just 14 kilobyte, very small neural network, run inside the DSP. So it will continuously listen for the OK Google wake up word, the wake word. And then they also have the limitation of 10 of kilobyte of the RAM and also the flash memory in the DSP. So the DSP is very small and it cannot do very heavy job. So how they're going to design a neural network that's so small and run inside a DSP? And it only require a few milliwatt of the power. It cannot consume too much of power because this thing is running inside a phone. So it's battery operated. So if this thing consumes a lot of power, then your phone got problem already. It cannot last for long. So this is one of the example that the very first some real application on how we run the AI in the digital signal processor. So this one is a very simple thing. So, but now for now, because OK Google is a very simple thing. If we want to do something more complicated, for example, for the computer vision, so we want to do some object detection on the embedded system like a phone. So that one will require more power. Of course, DSP not able to handle this thing. So they have a more advanced AI chip. So for example, they use just now the Mali GPU to do this thing. And this thing, it will consume more power compared to the DSP. So if the question just now, how are we going to apply this thing in the smart manufacturing? So it actually depends on your application, what you want to do in the smart manufacturing. Whether you want to analyze the voice or you want to analyze some image.
Let's talk about maybe a predictive maintenance that is very common. So certain vibration or certain set of temperature, vibration and pressure that can be sensed using some IoT sensors, and then it can fit into the AI neural network that they can design. Based on that type of modeling, let's say the model is small enough, so same thing you can do like what just Google is doing.
Yeah, if the model is small enough and then you're happy with the performance generated by the model, then you can do like that.
So just now you talk about this Google, it's basically those are in the Android phone that already in
Yes.
So maybe just now you say the other part is the Mali GPU. Maybe they didn't use a GPU yet.
I think that time Mali GPU haven't existed yet. Not yet.
So with the GPU, they can do this one more easily. Maybe they can do more functions compared to the previous.
Yeah, now the DSP is already dedicated just to listen the word, the OK Google word.
So I'm sure, especially on the vibration analysis. So also there are a set of digital signal processing that can be applied.
Yes.
So same thing they can do the same thing. So there are a lot of opportunities. There are a lot of this possibility in this AI chip. So well, I mean, if that is the direction that Malaysia is going through, of course, in the what I call in the event, so the PMX was talking about. The minister is talking about within these 10 years. 5 to 7 years is the first AI chip that this government is wanting to put up. Of course, within 10 years, we're able to ship. So, well, we can look into this part more later. So, okay, for that thing, just for those of you who has just joined in to watch us, you are watching the Sembang and Ujung Sembang IoT, my CCD.
Yeah, NL.
So we have just covered the AI chip thing. Because in the previous session, most of the time we are talking about those high-end GPU stuff, large language model. You need a high-end GPU, computer vision, edge computer vision, also quite. Of course, there are two parts: high-end GPU and also the lower end one. And so that's it. So today we do a little bit different. We point into the AI chip part of especially with ARM. ARM has been what you call, to me, ARM, of course, during maybe 20 plus years ago, when ARM started to come to the market, we are very excited. Everybody is very excited about that because very low power, things can, more and more things can be done in the electronics world. That is one of them. But after we do more high-end stuff, we forgot about this ARM thing. But of course, still carry along. There are something like that. For example, in this case, this is one of the NVIDIA Jetson module. This thing is produced by Maybe you can explain a little bit this one about that. But before that, do we have something? Have you finished your listing?
Still a lot.
Okay. So
I will move to the next slide. Yeah, so the constraint of the embedded device. So usually when we want to use the AI chip, so first there are a lot of constraints. It's not like the GPU that you always use, that you have a lot of RAM, a lot of processing power. So usually you come with maybe only a few hundred kilobyte of the RAM and the flash memory on it. And then the clock speed also very slow, 10 to 100 megahertz on it. So it's not very fast. And definitely you wouldn't get a full Linux. And even if the AI chip able for you to fit in operating system, you might not provide you any call it the POSIX or the standard C library function that you always use. A lot of things is missing. And then there's no dynamic memory allocation function. For example, the NIL, the malloc. So which means you need to define the address where you're going to store the value or the variable at where you need to define manually everything. So these are the constraints. So when you want to use an AI chip to do this kind of thing, especially you want to run AI, something that's more complicated. So we have this kind of challenge when you want to do this thing. So it's not something easy. That one is at a few years ago, but now they start providing a lot of library, especially when the AI getting more advanced. So I believe it will become more easier in the future for you to write your program in the AI chip. So we move to the next one. Yeah, so one of the deep learning framework that support the AI chip. So last time we call it the TensorFlow Lite. So this one allows you to run your AI model, especially the computer vision model, in the smartphone. So as long as your smartphone is not too old, there's a touchscreen one, you can run the TensorFlow Lite. But now they already renamed it to call it the Lite-RT, Lite Runtime. So the TensorFlow Lite, they will just rename it. So this one is from the Google. So last time, one of the very common deep learning model is called the MobileNet. MobileNet is a classification model. So based on your input image, it just classifies what are the things appear in the image.
This MobileNet is also part of the neural network.
Yeah, mobile is the name of a neural network.
Yes, a neural network also.
But now the Lite-RT, I saw they also can do a lot of things. For example, can do the image segmentation. They can do the super resolution. They can upscale your image from a low resolution to a higher resolution image. They do a lot of things already. But of course, it requires a more powerful AI chip to do it.
So you are saying, if let's say I'm having an ARM architecture thing, I can also, with this kind of Mali GPU, also I can do this thing.
Yes.
Enough to run that kind of model. Is it light enough?
Yeah, depends on what kind of model you use. Of course, mobile only for classification. If you want to do segmentation, you must use another model. So what the 𝐷𝐷 provide you a tools after you train your model. So it can help you to do the conversion into a smaller weight file that able to run inside your smartphone or embedded device.
Okay.
Yeah, so we move to the next one. Yeah, so what are the key features of the of the 𝐷𝐷? So first thing is the latency. So because everything you run locally, run within the chips, you don't have the latency issue. You don't need to send your data to the cloud server and then get back the data. So latency is the first one. And then the second one is the called size. Okay. So the size, okay, after you train your neural network, usually the neural network size is very big. So the 𝐷𝐷 provide the function for you to compress the neural network size into a small one that able to run in the embedded system. And then the third one is the power consumption. Of course, the AI chip consumption is very low compared to the GPU. And then the other one is size.
Power consumption, connectivity, size, latency. Cannot see.
I cannot see.
Connectivity, right?
One more is the security.
Oh, security.
Security because you didn't send your data to the server. So everything is run locally, the inference is run locally. Yeah. Okay. And then the middle one is, so the 𝐷𝐷 not only support the Android, it also support the iOS, and then the embedded system, the microcontroller also can run the 𝐷𝐷.
So, what's one question? The 𝐷𝐷 thinks that the model that you use, is it someone already trained or Google already trained for you, or you can also train your own yourself?
Yeah, we can use other deep learning framework, train our own model first, and then just use the 𝐷𝐷 to do the conversion so that it's able to run in the embedded system.
Okay. Then I can think of more possibility in terms of, let's say, ARM, they want to do further AI chip to do many other things. More dedicated tasks.
Yes.
For example, previously we used the analog meter, reading the analog meter. So with some little thing we can train, build in the camera, you can do this kind of stuff.
Yeah.
With more low power thing. Okay. That can be a lot of possibility.
Yeah, and then the right-hand side one is the framework that currently they support. So it support the TensorFlow, the PyTorch, and another one is the JAX. So they support these three framework. So as long as your model is developed using these three things, and can do the conversion using the 𝐷𝐷. Okay, so move to I think that one is the last slide, right? Okay.
Okay, so yeah, so after saying all these things, I think we seldom explore this setup. We seldom explore. By looking at it, based on what this government, Malaysian government initiative in terms of that, actually there are a lot of opportunity. Do you see the same thing? Of course, some of them are already available. Handphone already do. Yeah. But then, if let's say you want to expand to a certain thing, the similar concept can be applied. So there are more possibilities to be expanded from that.
I think we can start with all the sensor, because all the sensor they are usually low power. So if let's say the sensor now we can put in an AI chip, so everything, the sensor itself already can make the decision. So we no need to send the data back to a server, then wait for the server to make decision.
You talk about sensor, are you talking about Asian CCD?
Not any, maybe some vibration sensor, any sensor.
Okay.
Any battery power sensor, now you just put in the AI chip inside, and then the AI algorithm you want to run.
So it's another set of the world.
Yeah.
So that means sensors with the AI built in that can give you certain function.
Yes.
AI probably it can be as simple as machine learning. It can also be neural deep learning type of sensor. That is also possible. Wow! After talking about this part, our mindset will blow up to more possibility in terms of that part.
Yeah, actually, if without the AI chipset, then you need to send all the raw data to a server or a edge gateway to do the processing.
So that's why I think in this government initiative also, of course, there are more lights that you can see because in the old days, semiconductor industry in our country are mainly back-end packaging. Maybe we have a wafer fab, but then we are short of front-end thing. Front-end thing is to the designer. So with this kind of collaboration with ARM, I think there will be more and more possibility in terms of building different devices, applications, whether or not commercial or industrial, that can be more and more things coming out, especially when this high-end kind of AI semiconductor tends to have more kind of AI assistant to do development. So that can speed up the whole thing much faster. So that is one thing. So okay, interesting. So in order to close this part, I think we just want to bring just now I talked about this one halfway. Maybe we want to explain a little bit more here, from this AI chip from NVIDIA to this thing, Jetson thing from the future.
Yeah, of course. From the example that I give you just now, that one is very challenging. So if you apply the AI in over here, it's much more easier because it's this one is a NVIDIA Jetson Orin. Yeah, so it's a very powerful GPU inside, and then we also have the ARM processor. I think inside got 4 or 6 core, so it can handle a lot of things already. And then the RAM also quite big. You start with around 8 GB. I think this one.
This is 8 GB. There is another lower one for
4 GB. Yeah, at least got 4 GB.
So 8 GB one can support up to 1024 CUDA. This can go up. Of course, there is another higher version. So,
and then NVIDIA also provide the Tensor RT, the CUDA library. Very easy for you to do your own development compared to if you start doing everything from scratch from the AI chip.
Okay. So this one is very light. Actually, it's not light also, quite heavy because these are all aluminum. It's all fanless. Fanless. So what could be the application? Of course, fanless thing is good for place where environment is harsh, or on the train. You have that thing with the certification of vibration certified, and then on the mobile vehicle, things like that, all can be done using this part. Usually these are more used in computer vision, deep learning AI stuff like that. But we want to do
the robotic.
If you want to do for this sensor, you think able or not?
Overkill.
It's achievable, but overkill. This is very interesting. It comes with one of the 2 LAN port. One of the LAN port is actually PoE. You can put in the PoE.
Your PoE camera can straight away plug into there.
So this is very robust. I think that we have. Of course, just for your information, this is very new. Actually, it's considered quite new, So this Jetson O-ring, actually, they recently just announced it comes with a version of O-ring Super. Same thing, O-ring Super, but they update some of the library.
Or their jetpack.
Yeah, they update the jetpack and then they make it more efficient and more powerful. It's called called O-ring Super, Nano O-ring Super. Yeah. So with this 8 GB RAM, also you can do much higher. So at Exxon Tech, I think we are going to release O-ring Super very soon. Of course, you can go to our website for some of this data is already there, so you can enjoy this part. So maybe in the future we can do some demonstration on this adjacent thing. So by the way, before you go, I think this is the last part. Before you go, we have this. Me and General, we are doing some training program. Yeah. So that is called some AIoT, but more tailored to smart manufacturing. Yeah. To provide training to some of the SME, especially right now. Right now, actually, for the government, right now they have a Rise Forward 2.0, Rise Forward 2.0, which actually is a grant. It's a grant that allows you to attend this training for free. Of course, that is open to all these companies, especially manufacturing company, SME, manufacturing related services also fine, but then it has to be manufacturing as a base. So if you want to know more about that, maybe you can. Do we have any video to show? So this is QR code that you can scan. If you think your company would like to go into that, that is actually a grant. It's a grant, so you can come in to provide this type of training on IoT and AI. But then this training is tailored, to make use of technology to help increase your efficiency, to reduce the wastage, reduce the unplanned downtime, to increase your availability and traceability and so on. So that is very important. Of course, plus some of the predictive thing, that you can do. This is very hands-on training. If you are interested, maybe you can scan this QR. So we will connect with us. We will talk to you more about that. So with that, thank you very much for attending this Sembang AIoT session until the end. So we are on episode 89. We are going to 90. So thank you for watching. And if you find this session relevant, please do help us to share, like, and subscribe. Thank you very much. We'll see you in the next session. Bye-bye.